Welcome to September 29th LeetCode challenge. Split linked lists into parts. Given the head of a singularly linked list and an integer k, split the linked list into k consecutive linked list parts. The length of each part should be equal as possible, meaning that no two parts should have a size differing by more than one. This may lead to some parts being null. The parts that should be in order of occurrence in the input list, and the parts occurring earlier should always have a greater size than or equal to the parts occurring later. Return the array of k parts. Okay, so let's go to the example here. So we're given head of a single list to pointing to an array of three elements. So it'll be an array of 1, 2, 3, which demonstrates a singly linked list of 1 points to 2 points to 3. We're given k, right, which is the number of parts we have to split it into. So keep in mind, we want to think of two things, right? We want to do k divided by, I guess, the size of the linked list. And that means that k is larger than 3. That means we can't evenly distribute k at the head, the linked list into 3 parts. So that means you gotta have at least 5 consecutive parts, 5 parts. But some of the parts are going to have null in it because they can't fit anything, right? And we want basically the greater size value to be occurring before, right? Another word of saying the greater size or greater or equal to occurring later, meaning that the larger ones, the ones that have something, occur first. So essentially we split it to 5 parts. We will be 1 in the first element, 2 in the second, 3 in third, and then null null. Let's say another example. Here we have a singly linked list of 10 elements, right, ranging from 1 all the way to 10. We want to split into 3. So we want to keep in mind the same deal, right? If we take the modulus of 10 by 3, we get 3, right? Or we get the remainder of, let's say, 1, which is the extra part over. However, we do so basically we want to find the integer division of 10 by 3, and we also want to find the modulus to see if there's any extras left over, so we can add it to the first group. So if we divide the singly linked list of 1 to 10 by 3 consecutive parts, would have the first array containing 1, 2, 3, 4 because it's one higher, and the rest containing 1, 2, 5, 6, 7, and 8, 9, 10. So there's 3 items inside all of them except for the first one, which has an extra one. Value of the linked list node is between 0 to 10,000. Value is 0 to 10,000. Case between 1 to 50. Alright, let's look at the hints. N nodes of linked list and k parts. Yep, so basically showing n divided by k elements, except for the first part, which has n by modulus k, right? Which has an extra element. So we're gonna basically, in order to have n, I think we need to iterate through the linked list node first to count how many numbers of nodes we have in the linked list. So let's develop a count variable, which is going to keep track of a count of each node. And then I'm going to develop what's called a pointer or start pointer, and it's going to keep track of our current pointer. Let's call it start, and call it P actually for pointer, and I'll point it to head. So basic iteration when iterates through while the while P exists, right? We're gonna basically do P assigned to P.next, right? Which is the structure here. We want the current pointer to be pointing to the next pointer. We just do that. And then we will also want increment count, which is going to be k plus 1. So now we know the number of pointers. So I'm going to reassign the current pointer. So we could reuse this variable if we wanted, but I'm just going to say make a new pointer. So a couple of things we need to do is we need to basically, let's call it current, which is going to be assigned to head. And I also want, actually, I'm going to call this, current, and we'll call this, let's call this, so it's going to be using 2 pointers. I'm going to call this start, I'm going to call this n, and head, right? Start and end pointer. So those are the 2 pointers. We're gonna move them back and forth, and one's gonna exchange with another. I'm gonna also need 2 other variables to be able to keep track of the minimum length of each parts. So this part right here, n divided by k elements. So basically, that's gonna tell me how much the minimum length of each length of the chain, right? The each smaller array inside the larger array. So I'm going to call that length, and that's going to be the count integer division k. We don't want any floats or doubles there. Next thing we want to do is find the extra, right? There's an extra part left over. There's only an extra part left over if this has a remainder, right? If this, not this division by itself, but the modulus of the, we'll call it extra. And it's going to be count. Take the modulus with k. So if this has a remainder, then that's how many is left over is extra. That means we want to extend our couple arrays by extra. So we have those out, or we also want our output, right? Which is where it's going to be an array where we're going to append our answer to, or append our array of an array. So we have everything we kind of need so far, and now we just iterate through it again. So this is the first pass, counting how many nodes in the array. Then we do a second pass just to make sure everything is in check. So for each index in the range of k, what we want to do is basically we're iterating through each k elements, and we want to basically append the answer. So we append to the output, and that would be appending our start pointer. And then we iterate through using a for loop here. So for j in range of length, so that means right here for each length we have, each minimum length of each chain, what we're going to do is update our end pointer to be our start pointer, and then update our end pointer to be our next pointer after that, right? Dot next, because this end pointer is going to move all the way to the end, and this start pointer is going to hold whatever n is at the moment. I mean, it's poor naming, but I think it can make the point across. So that's one condition, right? If everything works out well, great. There's no extra, then we're done. But however, let's say if the number of the count of the head of the linked list node is not it's not an integer divisible number, so that means that there's remainders, then there'll be extras. So if extras exist, then what we're going to do is do the same things we did here. We basically hand over we assign n to be the start pointer, and then we do n next. I mean, n be assigned to n next. So we move both pointers again. This time, however, we have to decrement our extra. So extra decremented by 1. So we see how we go down here, and then if we basically we assign basically yeah, that's pretty much it. And then we have another situation actually. So if we're done, so right, if we exit it, so let's see if we've reached the end. Every time we're done this, every time we iterate through this first for loop, right here, we want to basically make n equal to none, or n.next equal to none, because we don't want anything to be captured after that. That's pretty much it. We want to return our output once we're done. Let's take a run here. Hopefully it works for a shot. Finished. Looks, oof. Doing something wrong here. Let's see. Extra decremented and next, boom, boom. Length, append start, okay. Extra. Let's see, what am I doing wrong? appending too many things. So for I in range of k, we're going to output.append the start of which is the head, which is next, right? For j in range of length, I'm going to do the end is going to do the start. Oh, I know what I'm doing. Start right here. When I move the pointers, no, not. Makes a lot more sense that way. Because we want to move the start pointer. Alright, let's submit that. Okay, accepted. Awesome. So this is basically a two-pass algorithm where we pass it once to count how many nodes we have. Then we basically go through the algorithm and we do a nested for loop here. But it's not. It's actually a big O of n times k, where n is the number of nodes we iterate through, and k is the number of, well, k right here, right, which is the integer we divide it into. Because we are making actually empty. We also need to iterate through and make empty lists too if it's not there, right? At the end of this, let's say we space complexity wise is big O of k, right? Because additional space is needed for writing the answer. Because in each of the output, we need to sometimes have empty as well. Alright, that's it. Have a great day, guys.